Need to get through the rest of this, so I'm going to start at number 8. Like I said, I think we got down to like number 12 or something in the other class, but I'm going to do a little repeat here because the stuff like for number 9 or 10 and 11 and 12 and so on, I'm going to do a little bit of, I guess, review before we get to that, and this is it right here. So let's take a look. Number 8. They give you 4 points, and they label the points. 1, -4, and point T is 512. Point M is -8.3. And then point V is -4.2. It's a weird looking 3. Let's write it like that. Alright, here's what they ask you to do. They say, let's compare line BT with line MV. So let's compare these two lines and see what's see if they're one of 3 things. If they're parallel, so we need to determine if they're parallel to each other. If they're perpendicular, I'll write up the whole word. Perpendicular. All right, or if they're neither. So here's what they're trying to do. And if you look at BT, look, here's point B, here's point T. All you need are 2 points to make a line. So these 2 points right here make a line. Let's everybody listen up now. Thank you. So I've got line BT and line MV, and I want to see if they're parallel, perpendicular, or neither. So what are you going to look at? What are you going to do to these 2 points to determine if they're parallel or perpendicular? What do you think? Find the slope. That's right. Find the slope of these 2 lines. So let's take BT and find the slope of those 2 lines. So I'll just put BT right here. Find the slope of BT. And here's the formula. Now, I said yesterday I was going to give you a little, like it's a formula sheet. So I'll probably put this on the formula sheet. I mean, it's something that you should have memorized, but I'll put it on the sheet for you. So let's just write it down. The slope formula is the change in y over the change in x. And that means you subtract the y's, put them on top, and you subtract the x's, and you put them on the bottom. All right, so I'll put it on a sheet for you so you'll have it in front of you. But you definitely need to know how to use the thing. So let's do that. Let's find the slope of BT right here. So that means I subtract the y's. You got to know which one are the y's. The y's are the second one, right? It goes x, then y. So you subtract those from each other and you stick them on top. So you go -4 minus 12. Now, it doesn't really matter what order you subtract them in, but you got to subtract the x's in the same order. So just to be consistent, I always do this. I always take the first one minus the second one. I just think it's easier doing it that way. So no matter if they're positive, negative, whatever the case is, I always take the first one minus the second one. Now, we did that for the y's and we put it on top. And now we do it for the x's and you put it on the bottom. So you take this 1 and that 5 and we'll subtract those in the same order. All right, I went the first one minus the second one. I'm going to go the first one minus the second one for the x's. And then you figure out what this is. That's -16 over -4. Always simplify your answer, and that's +4. It's not the answer. We're not done. We're comparing the 2 slopes to each other. By comparing the slopes, you can tell if those 2 lines are parallel, perpendicular, or if neither one of them are true. All right, so the slope of BT is 4. Let's do MV. And we'll slide it down here. So MV, let's find the slope of MV. So we do the same thing. Subtract the y's, put them on top. So our y's are 3 minus 2. Take the x's and put them on the bottom. Subtract them, put them on the bottom. So I've got -8 minus -4. Everybody with me so far? Finding the slope? Yeah, you're going to have to find the slope a lot of different times, and so it's important that you know how to find the slope. So let's figure out what this is. 3 minus 2 is 1. Minus a negative is plus, so -8 plus 4 is -1 or -4. So look at this slope. That's not my answer. I'm not really circling it for an answer. I'm just putting them in here so we can look at them. Yeah, let's compare these to each other and see if they're parallel, perpendicular, or neither. Well, look at them. They're negative reciprocals of each other, aren't they? Right? This is positive, this is negative, so that's the negative part. This is 4 over 1. This is what? 1 over 4. So they are negative reciprocals of each other. If they're negative reciprocals of each other, which one of them are they? Perpendicular, right. And so your answer, here's your answer, is perpendicular. But you had to think about it a little bit. You had to do a little bit of work to figure out if they really are perpendicular or parallel. What if they were parallel? What would be true about the slopes if they were parallel? They'd be exactly the same, right? Exactly the same. All right, they have to be exactly the same. But they are negative reciprocals here, so it means they're perpendicular to each other. Does that make any sense? All right. So we learned a couple things. We learned about the slope. That's very, very important. Okay, right there. We learned how to find the slope. That's probably the most important thing of this whole problem right here. All right. Tell you what, I'm going to skip number 9 because number 9 is almost identical to this. They give you different points for B, T, M, and V, and you do the same exact thing. On number 9, though, both slopes are exactly the same. Once you find the slopes are both exactly the same, so if they're both exactly the same, then your answer would be what? Parallel. Okay? So you can do number 9 on your own because I want to make sure I get through the rest of this test. All right, so now let's go to number 10. Let's go different color here. All right, let's take a look at number 10. It says write the equation in point-slope form. Now we're going to use point-slope form a few times on this test. So let's write that down and let's know how to find point-slope form. Point-slope form. Now again, I'm going to give you a formula, sheet for this thing, so you should know what it is. So it's y minus y1 equals m times x minus x1. All right, so there it is. That's the point-slope form. So you don't have to memorize it. I'll give it to you, but you need to know how to use it. So let's look at number 10. What do they give you? They give you a slope. All right, m. Remember, m equals slope. M is negative 3 over 2. And they give you a point, 7, negative 3. All right? So it's perfect to use the point-slope form. If they give you a point and they give you a slope, that's all the information you need to be able to put into the point-slope form. So watch how easy this is. But again, even if you know the formula, you still got to know what to put where. All right, there's one that's the most obvious. What's the most obvious one where you should put it? That's the slope, right? It's the m. All right, so the m is negative 3 over 2. So wherever that m is, you're going to put a negative 3 over 2. What about the x and y, though? You got to know where they are. So watch, it's y minus y1. Let's put that away, please. Yeah. Whole thing, sure. No, just half of it. Cut it into half and put half of it away. You can keep half of it.
Well, make sure you put the big half.
Put it all away. Come on, I'm being sarcastic. Put it all away. The whole thing. Come on. See, I'm not the only one, right? So look at this. This thing right here, we're going to put in for the m right there. So what's going to go in for the y or the y1? What do we put numbers in for both of those things? No, just the what? Just the y1, right. We just put a number in for the y1, and we just put a number in for the x1. Where do we get those two numbers from? From this, not from the fraction. The fraction goes in where the slope is. Okay, we get it from the ordered pair, right. Put it in the ordered pair. So the 7 goes where? That's the x1, and the negative 3 goes in for the y1. So it's just a matter of knowing what goes where and then just putting them in there. There's no math involved. You don't have to do any arithmetic. You don't have to know any math at all. All you got to do is just put these things in the right spot. That's all there is to it. Not that big of a deal. So it's y minus y1. y1 is negative 3. Equals m, which is negative 3 over 2, times x minus x1. So you write x there minus x1, which is 7. So look at this. Minus a negative. Minus a negative is positive. All right, you should always write it like that. Don't keep it minus a negative. Make sure it's plus. And then that's all you got to do. You don't have to do anything else with that. You can just keep it like that because the question says write it in point-slope form. This right here is point-slope form. What if? They don't ask you on this problem, but what if they said write it in slope-intercept form? Yeah, solve the equation for y. Exactly right. Get y by itself. So let's do that. So let's change this. And they don't ask you to do this on this test. All right, not on this problem anyway. But let's take this. Actually, now this is a little more... This is too involved because of the fraction. I'm not going to worry about that. On the next problem, though, we will. So we'll get to that in the next problem. So I'll keep that word slope-intercept form right there for you. Do you remember what slope-intercept form is? Good. Yeah, that's one that you should always have memorized. You'll probably never forget that one, right? Y equals mx plus b. So what we're going to do now is the rest of the problems, 11, 12, 13, 14, 15. Every one of those problems asks you to put the equation in the slope-intercept form. But I'm still going to use that point slope form. I'll show you what I'm talking about. So this is number 11. So let's write the equation in slope-intercept form of a line having a slope of 3. So m equals 3 and contains the point -5, -6. And there's my point right there. And what am I trying to do? I'm trying to put it into this form right here. I'm going to show you just a little bit of a different way than what I first taught it, because I did this in my honors class yesterday, and I thought, you know what, I should have just taught this way the first time. It would have made it a little bit easier. So look what they give you. They give you a point, don't they? And they give you a what? A slope. So if they give you a point and they give you a slope, it might be good to put it into the point-slope form. But after we put it in the point-slope form, we're going to have to change it into slope-intercept form. And you may look at that and say, well, that's too much trouble. Put it in one form, then putting it into another form. I actually think this way is a little easier than putting all this stuff into this. Because what would you have to do normally? Put the 3 in for the m, put the -5 in for the x, put the -6 in for the y, right? Then you would solve for b, and then after you solve for b, then you can put it all together. And that's not a problem. I mean, that's pretty easy to do. It's not really that big of a deal. But watch this. And you could decide which way you want to do it. I don't care. There's 2 ways to do this. You can do it either way. Let's put this into point-slope form. So we just finished talking about point-slope form. So it's y minus, what down here? -6, because that's our y, equals m, which is 3, times x minus -5, right? And watch, I think the math on this is just a little bit easier. It's not a whole lot easier, just a little bit. So let's see what we get. This is y plus 6 equals 3 times x plus 5. Now, what do we have to do to get it into slope-intercept form? Solve for y. Solve for y. So let's do that. Let's solve for y. And that's pretty easy, actually, to solve for y here. That's 3x plus, what, 15? Subtract 6 from both sides. All right, it's pretty basic algebra. 3x, what's that? Plus 9. And there it is. There's your answer, just like that. I didn't really teach it that way when we first taught it, but thinking about it as I did the review yesterday for my other class, I was thinking, you know what, this might be a little bit easier, so I think I'd show that to them. If you want, you could do it the other way, the way that I first taught. And how is that? I'll do this in different colors, so I'll show you the 2 different ways. You could do it like this. You could take that 3, put it in for here, take the -5, put it in for x, take the -6 and put it in for y, then solve for b. Let's do that. All right, so y equals mx plus b. So it's -6 equals m, which is 3, times x, which is -5, plus b. I'll tell you the truth, either way is just about as easy. It really doesn't make much difference. So let's solve for b here. -6 equals -15 plus b. Add a 15 to both sides, and then b is equal to 9. But we're not finished. That's not my answer, though, is it? I'm going to take my slope and take my y-intercept and just put those 2 together. So let's do that. Y equals 3x, right, because that's my slope, plus b, which is 9. And look, you get the same exact answer, don't you? It just depends on which way you prefer to use, okay? If you're probably thinking, well, I got to put it in slope-intercept form anyway, so I might as well just stick it into this form to begin with, right, and just work it out. And that's okay. I got no problem with that at all. I mean, that's how I first taught it to you. But if you wanted to use the point-slope form, some people like to do that better. So I'll give you a choice on that. All right, enough of that. Number 11. Or that was number 11. Let's do number 12. Let's go green here. All right, number 12. It says slope-intercept form again. Now this time, they don't give you a slope. They just give you 2 points. And you have to write it in slope-intercept form. You need to make this y equals mx plus b. All right? So what's missing that we had in the last 2 problems? The slope. Can we find the slope? Yeah, absolutely. So that's the first thing I'm going to do, because I need to put a slope here, don't I? So I need to find the slope. That's the first thing I'm going to do. And we've done that We did that a little earlier, finding the slope. A little crooked line. That's a little better. Okay, so change in y over change in x. So we subtract the y's, put them on top. Subtract the x's, put them on the bottom. Should be used to this by now. That's negative 12 over negative 3. What's negative 12 over negative 3? It's just plain old positive 4. So that's what's going to go in for m. What would you rather do? Would you rather use the point slope form or just plug them into this? Just plug it into this? All right, that's fine. So what are we going to do? What are we going to put in for the x and the y here? Pick a point. Right, pick one of them. It doesn't matter which one. The 5, 8. Okay, everybody says that. This is the third class period I've taught this problem. Every class period has said pick 5, 8. And I can understand that. Why would you pick 5, 8? They're both positive. Yeah, you don't have to deal with a negative. All right, I completely agree. That's probably what I would do as well. So let's put all the stuff in here. Look, I know an x, I know a y, I know an m. Let's plug it all in and see what we get. So what's the y? It's 8 equals m. What's the m? It's 4. I had to find that though, didn't I? Times the x. What's the x? 5 plus what? B, because I don't know what it is. So let's solve for it. 8 equals 20 plus b. Subtract 20. And b is, what's that, negative 4? All right, what did I put 12 for? Maybe because I was thinking what the answer is going to be. That's probably why I put it there. Okay, so it's negative 12. So look what we got. We got a slope. We got a y-intercept. And just put them all together to get my equation. So it's y equals 4x minus 12. And there's your answer right there. A lot of people have problems with this. I'm not sure why. If you go through it enough, if you do enough of these, it should be pretty simple for you. So what did we do? Found the slope. Plug in x, y, and m for my slope-intercept form. Solve for b. And then put it all together. There's my slope. There's my y-intercept. And I'm done. You got to practice these. If you think you're going to get this right on the test just because you sat here and you watched me do this, it's not necessarily true. You've got to practice these. I'm not giving you homework all week. All right, but that doesn't mean you shouldn't be doing math problems at home. You should be doing math problems at home. And watch the YouTube videos as well. Exactly right. But it's more important. Now, I keep harping about watching the YouTube videos, and that is helpful. But I think it's the best thing that you could do is actually do problems. You have a book, right? Look at problems in this chapter. Find the particular problems that we're doing. Find the odd ones because the odd answers are in the back. And practice those problems and see if you get the same answers that are in the back. That's what you should be doing. That's what studying is about. It's not opening the book and just reading the chapter. If you think that that's the way to study for a math test, you're wrong. The way to study for a math test is to actually physically do problems. If you do problems, that's the best way. You could watch all the YouTube videos. You can go to Khan Academy and watch all those videos. That's not going to help you near as much as you actually doing the problems yourself. Question. Number 13. Says slope-intercept form again. Now look what they tell you this time. This time they tell you the x-intercept. And they tell you the y-intercept. All right, we're not going to have a conversation back and forth here. It's not going to happen. So here we go. Stop talking, please. You're trying to play me, and I'm not going to take it. All right? No, you are. You are. No, you're not. I asked you if you had a question, then you didn't say a word. So you forfeited your right to ask me a question now. All right? That's how it works. Laugh if you want. Go ahead. That's fine. Look at this thing right here. The x-intercept. If you think about it, you don't have to draw this thing. I'm just doing this so you can visualize what's going on. The x-intercept is -6. So that means it crosses the x-axis at -6. But what's that actual ordered pair right there? Freddie, don't say that. What's that? What's the actual ordered pair right here? It's -6, 0. Freddie, what did I just say? I said don't do that. Put it away. I know. That's what I said don't do. So that point is -6, 0. All right, so watch. -6, 0. Really, that's all you needed to know. Because look, I've already been given the y-intercept, right? I want to put this in a slope-intercept form. Y equals mx plus b. All right, I've already been given the y-intercept, so I don't have to do any work to find the y-intercept. I don't have to find what b is because I already know what b is. I'm going to put it right here. What's the only thing I have to find now? Is the slope. All right. So I was thinking about putting this in for x and y. You could do it that way, but here's probably a better way. The y-intercept is 2, isn't it? So that would be right here. What's the actual ordered pair if the y-intercept is 2? It's 0, 2, isn't it? So what you can do, since you know 2 points, right, you can find the slope of it. Exactly right. So let's find the slope. Slope is change in y over change in x. So it's 0 minus 2 over the change in x, which is negative 6 minus 0. So that is negative 2 over negative 6, which is positive 1/3. Right? So the only thing remotely difficult about this problem is just knowing that the x-intercept is negative 6, 0, and the y-intercept is 0, 2. After that, it's really, really simple, because all I had to do was find the slope, and I already know the y-intercept, and now I can write my equation. So it's y equals m, which is 1/3 x, and then the y-intercept, we know it already. We don't have to solve for b. They already told it to us. And that's your equation right there. So if they tell you the x-intercept, you write negative 6, 0. They tell you the y-intercept, it's 0, 2. Notice, the x-intercept, negative 6 is the x part, and the 0 is the y part. If it's the y-intercept, look, the y is the 2. Everybody see that? The second part, and the first part is the 0. And that's all there is to it. Find the slope. We've done slope a couple times already today. And then you already know the y-intercept. Plug everything in, and you're good to go. So that problem gives people a little bit of trouble, this problem right here, because they're really not sure what that means, the x-intercept. But that's why I drew this little graph, just so you can visualize what that means to be the x-intercept. It means it crosses the x-axis at negative 6. All right. The next two cause a lot of trouble for people too. But let's try to make it as easy as we can. So 14. Again, we're writing the answer in slope-intercept form. So every time it says slope-intercept form, I'm writing y equals mx plus b. And look what it says. It says, for a line that passes through the point 8, negative 1, and is perpendicular. This was where it gets a little different. It's perpendicular to another line. And they give you the line, y equals 2x minus 17. Okay? Yeah, they do give you a slope, right? But they don't come right out and say, this is the slope, do they? But they do give you the slope, exactly right. So look what I have. I've got a point, and I have a slope. Is it 2, though? No, because our line has to be what? Perpendicular to this line. So if this slope was 2, we talked about this earlier, one of the first things we did today. If this slope is 2, what is the slope of a line that's perpendicular to this? It's the negative reciprocal. So this is positive, so what's our slope going to be? Negative. This slope is 2 over 1. What's our slope? 1 over 2. That's the trickiest part right there. If you can handle that right there, you could do this problem. I can almost guarantee it. So now we know a slope. Now we know a point. We can plug all this stuff in here, solve for b, and do what we've always done. Everybody with me on that? So let's do that. Let's plug stuff in. So y equals, we're going to plug stuff into this. What is the y? Where's my point? My point is right here, isn't it? 8, negative 1. So we put the negative 1 in for the y. So it's negative 1 equals m. I figured out what my m is, the slope, negative 1/2, times x. What's the x? It's 8. I'm going to put that over 1. Now don't flip out because this is a fraction. Okay, they rigged this to make it come out real nice and easy for you. So watch. What's half of 8? It's 4, and it's a negative 4. All right, so that's easy. Don't think, just because there's a fraction in there, it's difficult. They made it real easy for you. And now you just solve for b. So you add a 4 to both sides, and b is equal to 3. Now we're not done. We don't circle b equals 3. We have to write it as an equation of a line. We've done this several times already today. So it's y equals mx plus b. What's my m? It's negative 1 over 2, right? All right, there's the m, and there's the b. So y equals negative 1/2 x plus b. What's my b? It's 3, and that's the answer right there. So really, the only thing difficult about this was looking at the equation that they gave us, finding their slope, but changing it. Why did we change it? Because our line is perpendicular to their line. What if it said parallel? What if this was parallel to this? What would you do? You keep the same slope. Exactly right. You keep the same slope. So, funny I asked that because look at number 15. Number 15, it does say parallel, doesn't it? So it passes through the point 0, 7, and it's parallel, I'll put the parallel symbol, to this equation right here. All right? So it's parallel to this. So what do I look over here? I look over here for the slope. The slope is 4. So what's the slope of my line going to be if it's parallel to this line? It's going to be 4 as well. It's going to be the same exact thing. So now we just take this information and we put it into y equals mx plus b. This is about the third or fourth time we've done this today. So let's plug the stuff in. I always like to write y equals mx plus b first, and then I can plug the stuff in. What am I going to put in for y? I'll tell you the truth. You know what? I just saw this. Look at that point 0, 7. 0, 7 right there. What is that? That's the what? It's the y-intercept. That's right. Do we even have to plug anything in? No, because look, on this particular problem, it doesn't always work out that way, but on this one it does. On this one right here, they actually tell you the y-intercept, didn't they? So you don't even have to plug anything in. It makes things a little bit easier for us. So really, I didn't have to do any math at all because I just looked at this and I said, hey, wait a minute, that's slope is 4, our slope is 4. Then I looked at this point, I'm like, and I didn't realize until I almost started working on this. Then I looked at this, oh, 0, 7, that's a y-intercept. So the y-intercept is 7. So watch, I can just write it like this. Y equals what? 4x plus 7. And then I'm done. That actually was a lot easier than what people made it. Did that make any sense to you? If you wanted to, you could have plugged those numbers in, right? You could have put a 7 in for y, you could put a 0 in for x, and then solve for b. You could have done that. But I looked at this and said, wait a minute, that's a y-intercept. I'll just stick that number right here, take that slope, stick it right here, and I've got my equation of my line. All right, that's all the equation of a line stuff. Let's do something a little bit different now. And we're getting there. Let's see, let's use this tan color right here. Actually, let's draw my lines in white first, then I'll use the tan. So we've got a line that looks like this. We've got a line that looks like this. Copy and paste it and put it right there. Now if I copied and pasted it, what's true about these two lines right here? L and M, right? So the question says this. It says find x so that L is parallel to M. And they tell you this angle right here is 2x plus 6. And they tell you this angle is 130 degrees. They want you to find x to make these two lines parallel to each other. So we had a theorem that said if these two angles were what? Are we going to set them equal to each other? They're supplementary, right? Okay, so what we're going to do, if they're supplementary, then these two lines are going to be parallel to each other. So these are not equal to each other, are they? Look at this. There's no way that's equal because that's a acute angle. What kind of angle is this one? That's obtuse. There's no way an acute and an obtuse would ever equal each other. All right, so that must mean they are supplementary. So in order to be supplementary, what do they do then? Add up to 180. Good. So there's my 2x plus 6. I add that to 130, set that equal to 180, and then I just solve for x and I'm done. Pretty simple. That's 136, right? So subtract a 136, and that's what? 44, right? Divide by 2, x is 22. And there it is. That's all there is to it. The geometry is pretty simple. The geometry was just understanding that they're supplementary. All right? A lot of people, guess what a lot of people do to this problem? They set them equal to each other, but they're not equal to each other. And you got to look at it and say there's no way they could be equal to each other because that's an acute angle, that's obtuse. There's no way they're equal to each other. Okay, the only way they're equal to each other is if L and M were perpendicular to that line right there. That's the only way they would be equal to each other. All right? Make sense? What's the name of it? Do you remember the name if you have two parallel lines? They're not alternate because alternate, they're on different sides of the transversal.
consecutive?
They're not corresponding because they're not in the same. They're consecutive interior angles. That's right, because they're in between the two lines and they're on the same side. Remember in my other book, we don't really use this, but in my other book I called them same side interior angles. I kind of like that one better, but I use the term that this book uses. So, all right, this one looks pretty much the same. Let's make it look more like that. Let's push this up here about like that, and we don't need to have this sticking out so much. Okay, good enough. Let's put some stuff in here. This is M, this is L, and this angle is 3x plus 10, right? This angle right here. And this angle over here is 4x minus 10. And we want to find what x is equal to in order to make these two lines parallel to each other. Now look at these angles. They're alternate exterior. Very good. They're alternate exterior angles. And what's true about alternate exterior angles? If I could speak, alternate exterior angles, they're equal to each other. Exactly right. So on this one, we don't add them up and set them equal to 180. The geometry was just to realize that these angles right here are equal to each other. So we set them equal. So 4x minus 10 equals 3x plus 10, and then you just solve for x. Subtract 3x from both sides, that gives you x. Add a 10 to both sides, that gives you 20, and you're done. Just like that. All right, let's do another one. Same kind of deal. It's really not much different. This looks a little bit more normal, right? The way we first learned it. This is L and M. Let's go different color here. All right, and this angle up top here is 6x, or in the middle, 6x plus 4, right there. This angle down here is 8x minus 8. All right, let's take a look at these. We got to find what x is to make L and M parallel to each other. So what's true about this angle and this angle here? They're equal to each other. What would be the reason? Alternate interior angles. Very good. Now they don't ask you to tell me the reason, but it's nice that I know you know. Okay? So what's true about alternate interior angles? They are equal to each other. So we do the same thing. We set them equal. But don't just get so used to setting things equal to each other that you do that every single time. Make sure you know why you're setting them equal to each other. That's very important. Subtract 6x from both sides and you get 2x. Add an 8 to both sides and you get 12. Divide both sides by 2 and you get 6, and you're done. Got it? Showed my work, but I didn't have to show every little tiny step, right? I could do a little bit in my head right there, but I did show the work, and I showed why that answer is what it is. All right. We're almost done. Let's draw this. This is easy. There's really no math involved in this. It's just understanding what it means to find the distance between a point and a line, or a point and a line segment. Hopefully you remember this. Still, I got several people that got this wrong. Most of you got it right, if I remember right. And you want to, it says, copy it on your answer sheet, construct the segment that represents the distance indicated. Well, here's the distance. You want to find the distance from C, I'll put that word in there, from C to line AB. All right? So what I have to do is it says construct or draw a line that goes from C, the distance, I should say, not just any line, the distance from C to AB. Well, where are we going to start? We're going to start right at C, and we're going to go to AB. So does it matter? Can I just go right here? Can I go right here? Can I go to A? Can I go to B? Where do I have to go? Straight down? Give me a better word than that. Perpendicular. Okay, perpendicular to this. Is that enough right there? Can I just, you got to put the little square thing, right, to show that it's a right angle. Okay, if you don't have that little box, I marked it wrong. And I can't remember who it was, but I do remember somebody complaining that I marked it wrong because you didn't put the box there. All right, forget who it was, but somebody complained about that. But what did I say many, many times before I gave you this test? I said that if you don't put the box there, it's going to be wrong, didn't I? All right, and you know, I stuck to my word, and I had to mark it wrong because if you don't put it here, this does not tell me it's perpendicular. You've got to tell me it's perpendicular. I know it seems picky, but it's important because that's the whole idea. The whole idea of this problem is to see that you understand what it means to find the distance. The distance is always perpendicular. All right, let's draw this one. This is kind of the same thing, a little bit trickier. It's got a little bit of a twist to it. A, B, C, D. And you are finding the distance. I should write that in here, because that's a pretty important word here. The distance from point D to AB. All right? From D to AB. There's a little problem, though, isn't there? Do I go to here? Do I go to here? 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 No. Let's not say straight down. What do we say? Perpendicular. No, not completely straight down. All right? This is straight. That's a straight line. I mean, I know what you're saying. I'm not so out of tune where I don't know what you're thinking. But I want you to say it the correct way, though. All right? I want you to say it the correct way. It's what? It's not straight down. It's perpendicular, okay, to the base. Problem is, where's AB? AB's way over here. So what am I going to have to do? I'm going to have to extend it, aren't I? All right, so I'm going to have to extend it. I could extend it way out here if I wanted to. And so now let's try it again. Now I can go perpendicular. Everybody see that? Now you could put a dotted line for the extension if you want to. It's fine. I just extended that line. Is that right there? No, I got to do what? Do that. Make the little box, okay, to show this perpendicular. So that's your answer right there. That red, everything in red, plus that little extension, that's your answer for that problem right there. We good with that? Well, that would be number 20, and that's the test. Let me show you something real quick on YouTube. They've changed things up a little bit, so I want to make sure that you know how to find the videos, okay? So don't pack up yet.